Graph shows the variation of velocity with time of a body moving in a straight line with varying acceleration. The equation for the graph is v equals t square. Our interest is to find the displacement of the body in the duration from 1 second to 3 seconds. Since the velocity is varying and we have a formula for displacement only when velocity is constant, we have to find a different method to take care of the variation. Our plan is to divide the duration into number of intervals and calculate the displacement in each interval by assuming the velocity for that duration did not vary. The equation for this is shown in the bottom area. Displacement equals sigma n equals 1 to n equals n of Vn delta t, where Vn stands for the velocity for the interval and delta t is the length of the interval. Let's start by doing that by considering two intervals. We will consider the entire duration as two intervals of 1 second each. If the velocity at the beginning of the first interval is seen as the velocity for the entire interval, this will give us displacement equals 1 meter per second into 1 second, which equals 1 meter. For the second interval, the corresponding values are 4 meter per second and 1 second, and the displacement is 4 meters. So the displacement for the duration of 2 seconds is 5 meters. This calculation is shown in the bottom area. In the graph, this calculation is shown as the area of the gray rectangles. The height of the first rectangle is 1 meter per second and its width is 1 second, which gives us the area as 1 meter. For the second rectangle, the height and width are 4 meters per second and 1 second, and the area is 4 meters. These areas add up to 5 meters. Alternately, if the velocity at the end of the interval is considered as the velocity for the entire interval, this calculation gives us 4 meters for the first interval and 9 meters for the second interval, which sums up to 13 meters. In the graph, this is the area of the gray and the orange portions together. The heights of the rectangles are 4 meters per second and 9 meters per second, and the widths are 1 second each. This calculation is shown in the black area. And these values are shown in the first row of the table in blue. Do pay attention to the values in the last two columns. The difference between these values is 8 meters. Let's increase the number of intervals to 4 and repeat the calculations. Since the width of the rectangles are equal, let's add up the heights and multiply that with the common width. This gives us a value of 6.75 meters and 10.75 meters, with a difference of 4 meters for the lower and upper estimates. With 8 intervals, the lower and upper estimates are 7.688 meters and 9.688 meters, and the difference is 2 meters. With 16 intervals, they are 8.172 meter and 9.172 meters, and with 32 intervals, the corresponding values are 8.418 meters and 8.918 meters. The lower and upper estimates are getting closer as the number of strips increase. The rectangles have become very thin, and showing any more of them will fill the entire area with a single color. So we will switch to just making the calculations which are shown in the table. As the number of intervals increase, the lower and upper estimates approach each other and the difference gets smaller. For 8,192 strips, the difference is 0.002 meters. That's a good result, but we do not have to stop there. We do the calculation starting with n as finite and replace n with infinity at a stage of calculation where it does not yield an acceptable answer. This calculation done when n tends to infinity is called integration. In terms of the graph, you are finding area bound by the curve, x-axis, and the lines parallel to y-axis which define the limits. In this case, it is area bound by the curve, the x-axis, and the lines t equals 1 second and t equals 3 seconds. The first equation on the right is a sigma summation for finite number of intervals, and the second for n tending to infinity. This gets a special symbol, a stylized S. Lastly, the mathematics of doing the integration calculations is simple. All you need to ask is which function must be differentiated to get t square. Your answer would be t cubed by 3. And when you substitute the limits of 1 second and 3 seconds, you get the required result.